Welcome to the video demonstration of Big Cloud Fabric P plus V Fabric Edition with Red Hat OpenStack Platform RHOSP. Big Cloud Fabric P plus V Physical and Virtual Edition provides a single pane of glass for both physical and virtual networking. BCF P plus V Fabric has advanced integration with OpenStack Neutron, which enables fabric config automation for the tenant application network topology, including layer 4 to 7 service insertion. BCF P plus V Fabric also provides distributed logical routing and distributed NAT for floating IP across OpenStack cluster with SwitchLite Virtual. BCF P plus V Fabric also provides OpenStack Horizon extensions to enable the tenant-driven troubleshooting and tenant-driven service insertion. I'll be demonstrating Big Cloud Fabric P plus V edition in three parts. First, I will demonstrate how BCF controller provides the single pane of glass for managing both physical and virtual switches, which are auto-discovered. Secondly, I will show OpenStack tenant workflow for application deployment to show how dynamically BCF P plus V Fabric gets provisioned for both layer 2 and layer 3 networking. Finally, I will demonstrate how BCF extends the test path and fabric analytics to SwitchLite Virtual to enhance the visibility and troubleshooting in the BCF P plus V Fabric. To demonstrate that, I will be using BCF 2-rack topology with 4 compute hosts, which are part of Red Hat OpenStack Platform RHOSP OpenStack cluster. As part of initial deployment, the OpenStack cluster is installed with Big Cloud Fabric plugins for OpenStack Neutron, with SwitchLite Virtual installed on all the OpenStack compute nodes. Let's look at how BCF controller provides the single pane of glass for managing both physical and virtual switches. This is a BCF controller web interface. Fabric view shows the physical topology used, in this case 2-rack topology. Mouse hovering on any of these switches shows the information about that particular switch. With the Big Cloud Fabric P plus V edition, the Fabric view shows the hosts running SwitchLite Virtual at the bottom of the Fabric page, and these are auto-detected and managed by BCF controller. This is Virtual Switch over Cloud Compute 0. If you click on the virtual switch, on left panel it provides additional details on the virtual NIC, where VMs are connected, and uplink ports where it is connected to the physical leaf. Similarly, I have 3 other virtual switches in the OpenStack cluster. If you want to see the SwitchLite Virtual associated with the particular rack, then click on the leaf switch for that rack. For example, if you click rack 2 leaf, shows virtual switches connected to that rack 2. And similarly, these are rack 1 connected virtual switches. The single pane of glass for managing both physical and virtual networking enables BCF to provide better visibility, which will help in troubleshooting network issues, both physical and virtual, which I am going to demonstrate in the later part of the demo. Let's look at the OpenStack tenant workflow for application deployment. The Big Switch OpenStack Neutron ML2 driver and Layer 3 plugin enables dynamic provisioning of Big Cloud Fabric for both Layer 2 and Layer 3 networking, as and when OpenStack tenant creates network and router on Horizon dashboard. BCF also handles the floating IP and the NAT as part of the auto provisioning. Let's look at the OpenStack Horizon dashboard for Blue tenant. This has been configured with 3-tier application, web, app, and DB tier, with each of the network having 3 VMs, and tenant blue router interconnecting them. BCF tenant view shows the tenant blue, which is auto-configured through the OpenStack plugin. Now let's look at the BCF tenant detailed view. The logical topology shows the 3 tiers on BCF as well with the logical router. Logical router interface IP addresses are shown on the segment. If you look at the configuration view, it shows the 3 segments in the tabular view with the logical router interface IP addresses, which will be used as a gateway by all VMs in that network or segment. NAT profile shows the provider IP used for port address translation by tenant router for north-south traffic. BCF also provides the visibility into OpenStack tenant security group configuration. Now let's create new tenant network topology for a red tenant on OpenStack and see how it dynamically gets provisioned on Big Cloud Fabric. Log in as red tenant user on Red Hat OpenStack. Let's go to network topology page. As you see, no networks configured other than the external provider network. Let's use the OpenStack Heat network template to deploy application network topology. That is the enhancement BCF Horizon extension provides to user, which makes application deployment faster and simpler. Let's use 3-tier app template. Change IP subnet for each of the tier as per your need. I'm using 10, 100, 31, 32, and 33 with /24 mask. Apply the template. The networks and tenant router gets created as defined in the template. Now let's Switch to BCF controller and refresh the tenant page. New tenant red got auto-configured on BCF through BCF OpenStack Neutron plugins. If you click on the tenant red, it provides the logical topology for the red tenant with 3 segments or networks and logical router with gateway IP address for the given segment as configured on OpenStack dashboard. Let's add instances or VMs to this tenant. Add 3 VMs each in each of the network. First, web VMs. Choose the web network. Similarly, create 3 instances in the app network, 3 instances in database network as well. Now all the instances are up and running. Let's go to BCF endpoint table. All the new VM endpoints corresponding to the new red tenant have been learned, and the table provides the details about the endpoints, IP and MAC, virtual switch, and virtual NIC where it is connected. In addition, BCF P+V enables the tenant-driven layer 4 to 7 service insertion like firewall using router policies through the Horizon extensions. Under Network Fabric tab, tenant defines router policies from the OpenStack dashboard, and the policy gets auto-configured on BCF. That's how BCF OpenStack Neutron plugin automates provisioning of the Big Cloud Fabric P+V Fabric for Layer 2 and Layer 3 networking, and also Layer 4 to 7 service insertion for OpenStack tenant workloads. Let's look into a visibility and troubleshooting aspect of Big Cloud Fabric. Big Cloud Fabric P+V edition extends test path and fabric analytics feature to provide visibility and troubleshooting to virtual switches. First, we'll look into test path feature. BCF test path feature, which is visibility feature used for troubleshooting connectivity issues between the endpoints in the BCF fabric, extended to trace path from and to virtual switches in the unified P+V deployment. Let's do test path between 2 endpoints. Pick source endpoint in blue tenant web segment, say 10.100.41.4, and destination endpoint in app segment 10.100.42.4. Let's run simulate mode. This provides both logical path as shown on top and physical path as shown on bottom of the screen. Logical path helps in understanding the exact routing and policy configuration. If there is any misconfiguration, the logical path would indicate that. Physical path view provides the exact physical path. With P+V, it includes source virtual switch, in this case over cloud compute 0, and also the destination virtual switch over cloud compute 1, where this particular endpoint resides, and also provides the physical leaf and spine switch details. Mouse hovering on each of the hop on both logical and physical path would provide additional details. For example, hop 2 in logical path provides the logical routing between web and app segment, including the applied policy for the given flow. BCF Horizon extension extends this test path reachability test tool to the OpenStack tenant. Let's go to the blue tenant network tab, network fabric page, which shows features enabled by BCF Horizon extensions, including the reachability tests, where tenant can create the test, run the test, and save the test. Let's run the save test between the blue web and app VMs as we tested on BCF controller. Test ran successfully. Click on the result for details. It shows exact physical path from source virtual switch over cloud compute 0 to rack 2 to spine to rack 1, and then destination virtual switch over cloud compute 1. Big Switch Horizon enhancement enables the tenant to do quick reachability tests to validate the network configuration in case of any application connectivity issues before opening ticket with networking team. The test path test mode would give even more granular result compared to simulate mode, which provides the ingress and egress interface at every switch, both virtual and physical, for the given flow. For this test, hop 0 is virtual switch over cloud compute 0, ingress interface is virtual NIC QO interface, egress interface is P1, then hop 1, which is R2L2, Ethernet 22 is ingress, and Ethernet 49 is egress interface. Hop 2 is spine S2, which receives the traffic on Ethernet 24 and sends it to the next hop on Ethernet 22. Similarly, hop 3 switch R1L1 and hop 4 over cloud compute 1 provides the ingress and egress interface details for the given flow. Now to demonstrate the distributed floating IP implementation, let's trace the path from Web1 host, which is having the floating IP, to the internet IP, say 8888, which is public DNS server. From logical path, you can see that the traffic is getting natted, as traffic is meant for external to the fabric and source has floating IP assigned. From physical path, you can see that floating IP is implemented locally on the source virtual switch over cloud compute 0 and then sends traffic to external core router after doing source NAT. That's the other benefit BCF P plus V fabric provides, which distribute the floating IP NAT implementation across the OpenStack cluster on virtual switches. That's how BCF test path simplifies the troubleshooting for both BCF administrator and also OpenStack user to debug the application connectivity issues. Next, look at the BCF Fabric Analytics feature, which is extended to provide visibility into the virtual switch along with physical switches. The dashboard shows the graphical representation of all the physical and virtual switches and the events associated with it. You can click on the switch name on the pie chart to get the events associated with that particular switch. Bottom of the screen provides more details into the events and the time window. In summary, BCF P plus V Fabric provides advanced integration with OpenStack, which enables auto discovery of virtual switches, Fabric config automation for tenant application network topology, including layer 4 to 7 service insertion. BCF P plus V Fabric also extends the visibility and troubleshooting tools to virtual switch and to the tenant from OpenStack dashboard. Thank you for watching.